Okay, so I've just purchased this Egscatee, as they pronounce it. It's an Egscatee. It's a 5,000 watt with a 2,500 watt continuous supply. Now, I've got the old cheapo snack old DC amp meter connected. It's set to 60 amps. Don't know if you can see that. But 600 amps, sorry. At the minute we're drawing at 1.4 amps. I've got the kettle plug lead in, but not connected. The only thing I've got charging up is my phone, and it was dead 2 minutes ago and it's now at 6%. It has a remote on and off switch, so sorry about that. Switched on, off I mean, and then switch on. And it's resumed charging. Right, so what I'm going to do is I'm going to test. It's a 24 volt, by the way, input with a 220/240 output. Okay, so we've got the amp clamp meter, the DC clamp meter on it. This you can ignore because I'm just currently charging up this one battery with 3 chargers, so of a total of 15.5 amps going in there, but that's irrelevant. That's just me charging that battery. This test is purely for the inverter. Okay, so we've got the kettle. This also is a Lizlark kettle from Temu, 10 quid. Works fine. And the reason I purchased that is because it's a 15 to 1800 watt kettle. And my old kettle was like 3000 watts, and I want to run it off this. This is for a van setup, and I want to run a kettle off it. So I've got the lower wattage kettle, and we're going to test it now to see what it does. And what I'm going to do is I'm going to test it with 800 mils of cold water, fresh cold water out the tap, out the ground. Okay, so we're going to put it on here, we're going to see it boil, and we're going to calculate how long it takes. And then what we're going to do is we're going to cool the kettle down back off again with cold water, add another fresh batch of cold water, and then we're going to plug it into the grid and see how many seconds it takes for the grid to do it, so we can compare the time difference between the two. So let's fill that up. We want 800. I've got that. That's 9. Oh, stopped it bang on 9. Take some out. What's that? Yeah, that's excuse me, bang on 800. So we've got 800 mils of cold water, and that is cold water. That's the cold tap, that's the hot tap. You can see the red label on that, cold on that. Freezing cold. Even put my hand in it. Now I've just removed about 4 grams of water. Never mind. Anyway, so close lid, and let's do it. I've still got the same kettle in my hand. No, I haven't swapped it out. Right, so what should we do first? Start the kettle or start the timer? And we'll start the timer, start the kettle. There you go. So they're both on. Timer's run 7 seconds. You can see the lights on the kettle. There's no other wires. This is all the remote switch. You can hear it starting already. The minute we're drawing 68.6 amps. Turn the light on. And that didn't make no difference. So 69 amps DC. And obviously it's not making any difference to all this because obviously that's all irrelevant. Okay, so move this over here so we can get it all in view. Still 69, 69.9, 70 amps. About 70 amps. There's no heat in that cable, none whatsoever. I mean, I do have a heat gun, but I can tell you now that is stone cold. That is probably body temperature. So we're at 1 minute and 44, 800 mils of stone cold water out the ground in the UK. It's winter time, so you know what I mean. It's not much above freezing. Probably what, 5 degrees. 2 minutes, and the fan has just come on, but oh, it's gone back off. So the fan's kicked in, even though it's slightly warm. Kicked in for about 2 seconds. Oh, there you go again. So you can hear that. Yeah, they keep flashing on and off. The ground cable is body temperature, and same with the doodah, the positive. And I mean, look, my fingers are on it. Freezing cold, body temperature, that's all that is. So, and that's not even much above body temperature. I'd say that's around about, I don't know, 55 degrees. And we're at 3 minutes. Plug's freezing cold, cable's cold. That's hot. Ice wine, that's hot. So 3 minutes, 18. And this just keeps cycling on for a second or two. That's good. You can hear it. Let's get that in shot. You can see this will click off itself. There you go. So 3 minutes 40 seconds. Okay. Amps have dropped that down. Let's cycle on again. I mean, it's only going up to 1.7. That's a good, I mean, that's idle with my phone charging the 1.4 amps, and it's only jumping to 1.7 when the fan kicks on. 1.9, 1.7, 1.8. Just for them few seconds, just to protect it. But yeah, I think that's pretty good. So now what we're going to do is we're going to do the same test, and we're going to put the kettle in the grid and see how many seconds that takes. So we'll empty this water out. Let me set this up so you can see what I'm doing. Where am I going? If I can set this up. That's good enough. Right, so my phone's charging. I need the power supply for the grid. Plug that in. That's on. Cold water. Pull down the kettle. $800 again. You probably can't tell, but it needs a little bit more. Hang on. We'll put that in here, stone cold water. Stone cold. Here we go. So now we're going to put it on the grid. Get the timer. Now, last timer the inverter did it at 3 minutes and 44 seconds. Let's see how long this will take. Whoops. So reset that. Start the clock. Start the kettle. Oh, it's doing on the storm. Let me put that there. I can put that there. Just leave that like that. Put something there to rest it on. I'll turn that like that. You'll see the shut off when it's done. One minute 4, 1 minute 5, 1 minute 6, 1 minute 7. Now in theory, I'm expecting that to be 3 minutes. Two minutes 12, 13, 14. This is a good experiment. had a very shiny nose. Yep. It's 3 minutes. Ooh, it could be very, very close. Very close. Come on. Nearly there. The race is on. Song streets between the inverter and the grid. Ooh, come on. Is it gonna beat the inverter? Is it gonna beat the inverter? I don't think it's gonna beat the inverter. Oh wow. Wow. 3 minutes 50. Wicked. Well, there you go. So that's it. So it took the grid 3 minutes and 50 seconds to boil 800 mils of stone cold water, and it only took 3 minutes and 44 seconds for that inverter, 24 volt to 220 output, 240 output. So there you go. Thanks for watching, and don't forget to subscribe and to ding that bell. See ya.